So currently we are at this step, which means we are talking about step-by-step method to find solution of Ax equal to B. Now let's just solve this question. So they are saying, suppose a matrix A that is having dimension 20 into 50 has 10 pivot columns, right? So then in that case, how many linearly independent columns in A and how many linearly independent solutions in Ax equal to 0? See, these two things are little different in the sense that if you are thinking about it, then you don't have to think about Ax equal to 0. I mean, this is the columns in A, linearly independent columns in A, and this is about Ax equal to 0. So don't get confused in these two. Now, if I ask you that how many linearly independent columns in A, that is just a pivot element. And what is given here? They are giving that 10 pivot elements are here. So that is very straightforward that 10 is the answer in the second option or second question. Now let's just talk about the first question. Number of linearly independent solutions in Ax equal to 0. Now let's just bring it here. So it means number of linearly independent solution means that how many free variables you have, right? So free variables. If you have 3 free variables, then there will be 3 linearly independent vectors, something like that, such that you will be having S, T, U, and there will be a summation of 3 linearly independent vectors in the solutions of Ax equal to 0, right? So if they are asking about Ax equal to 0, then you just have to think about the free variables that you have. So these concepts actually will also be useful in eigenvalue, eigenvector. I will tell you how. But for now, just try to understand the things that if they are asking about linearly independent solutions, okay, in Ax equal to 0, solutions in Ax equal to 0, it is a free variable. So which means if total you have 50 variables, so you have 50 minus 10, which is 40 free variables, right? I hope you understood. So 10 are pivot columns and 40 are free columns or the free variables. So 40 and 10 is the answer. Linearly independent solutions in X equal to 0 is 40 and linearly independent columns in A is just 10. Now let's just solve this question which I gave you as a homework. So what they are saying, suppose P is 4 cross 5 matrix such that every solution to the equation Px equal to 0 is a scalar multiple of this, which means they are saying that the solutions of Px equal to 0 looks like this, 2, 5, 4, 3, 1. They are saying that every solution of Px equal to 0 looks like the scalar multiplication of this matrix or of this vector. What does this mean? It definitely means that number of free variables, if you can tell me number of free variables, then what will the answer? Number of free variables will be, just think about it, 1, right? So number of free variables will be 1. It means number of pivot variables will be 4 because total variables are 5. Number of pivots equal to 4, and that's what the rank is. So that's why the rank is also 4, right? Very easy question, but this question could have been so tough if you do not know the basics. So just do one thing, just go to gate overflow and check if people are getting to understand this particular question or not. So see, we solved it with very ease. You might not feel that this question is tough, but if you imagine you do not know the basics of all of this, like what I told you, then this question could have been very, very tough. Just go to the gate overflow and see that how much people are struggling just with this question. Okay, if possible, answer there in such a way that even non-Go classes student can also understand that answer. Okay. Now let's see this question. They are saying consider a matrix which is having A which is 8 into 9 dimension. Suppose a system Ax equal to 0 has a non-trivial solution such that the solutions are linear combination of 3 linearly independent vectors. Okay, it means what? The free variables in A equal to 3. So the pivot variables will be 9 minus 3 equal to 6, which means these are linearly independent columns in A, right? So this is 6. That's very easy question, but yeah, like if you understand that, then you can easily solve it, easily solve this question, right? Now let's just see that how to solve non-homogeneous equations solution in the parametric form. Although we have already solved it, but I wanted to solve one more question, and there I will convey one thing. So we already solved one question which is related to this particular matrix A, and then we have already solved for Ax equal to 0. If you don't remember, then let me just recall you. This is what lecture 5 annotated notes look like, and if you go to the lecture 5, then you can see that we have solved this question where we were solving for Ax equal to 0, right? This is the same question. So this is x, y, z I said this is x, y, z, w. Okay. So we solved the same question in lecture 5. See, this was the answer that we were getting. Now, I want to solve the same question, but not for x equal to 0. Now this time, let's suppose a is same, but b is some different. I mean that instead of 0, I have some b. And I want to solve for x equal to b. Okay. So now let's solve the non-homogeneous equation and let's just solve for x equal to b. Let's see what we are getting. So, okay, let me try solving it. Maybe I can just copy it. And then let's just solve it. So you have 2 here. Okay, this matrix is not that huge, so I can just make it like this: 2 1 1 1 minus 1 0 2 3 and then 0 minus 2. Now if you notice, you can make this 0 by making R2 can be replaced by R2 minus R1. So you will be having 2 1 minus 1 2 0 and then 0 2R2 2R2 which will be 2 minus R1, it will be 1. So 0 minus 1 plus 1. 6 minus 4 will be so this is 6, this is 2. 6 minus 2 will be 4 and then minus 4 minus 0, it will be minus 4, right? So earlier also I got the same thing, right? I think so. This is 0 1 1 4 0 1 1 4 and then now this time you have 0 minus 4. So let me just copy this, that what we got. So this is what we got, right? Okay. Now let's just solve for this. So if you remember, this was x, y, z, w. Now this is the pivot variable, this is the pivot variable. So the very first step is to write the free variable, which are z and w. Okay. And now let's assign the value of z to be s, w to be t. Now you will solve for by, then you will say that by plus z is s plus 4t equal to minus 4. So from here you will be getting y, which will be minus 4 minus s minus 4t. And then similarly you will be getting x from here. So I think x will be same as previous, right? Because it is 0. Anyway, let me just solve for the x. It will be 2x plus by. By is this much, which is actually minus 4 minus s minus 4t minus s plus 2t. Okay, x will also be differing because by has differed, so x will also be differing, equal to 0. So from here you can find out the value of x. This is minus 2s, so it will be plus 2x here. This is minus 4, so it is plus 4 here. So s is okay, 4 is okay, and then this is minus 2t, then it is plus 2t here, right? So finally let me write the value of the vector x, which is the final solution. So the first is x 2s plus 4 plus, let me write in this way, 4 plus 2s plus 2t, and then this is minus 4 minus s minus 4t, minus 4 minus s minus 4t, and then this is s, this is t, right? Cool. Let me verify if we are getting the same answer. 2 plus s plus t. Okay, that was 2x actually, that was 2x, and then finally you need to divide by 2 also. So it is 2 plus s plus t. This is plus, this is 2 plus s plus t. Then minus s, minus 4 minus s minus 4t. Yeah, that is correct. So x is this, right? Earlier we got different x, but that's fine. Earlier means like when we solve for this. I think this was the x we got. S plus t, it was there, but it is something else here. Now it is minus s minus 4t, it was there, but it is something else here. Good, not an issue. But earlier, if you remember, I decomposed that into two parts. How? I put s equal to 0 and everything else to be non-zero. S equal to 1 and everything else to be 0. T equal to 1 and everything else to be 0. But here we will be doing one extra step, which is that we will be putting all of the variables, which means s and t and any other variable whichever we have to be 0, and we will be getting one vector, which is 2 minus 4 s and t. Sorry, 2 minus 4 0 and 0, right? If you put s and t as 0 0, then you will be getting this as one vector. And then plus. What you do, you write apart from this vector, which is, I mean, apart from, you actually just bring out the constant, and then you write s plus t, you write minus s minus 4t, you write s, you write t. So basically what we did, we just decomposed into two parts. One is that we wrote the constants that we have here, and we wrote s and t separately. Why we did so? Because we know how to decompose this kind of vector. How? We did this in the homogeneous. See, in case of homogeneous, we broke this particular vector, or we decompose this particular vector into two vectors by putting s equal to 1 and t equal to 0, by putting t equal to 1 and s equal to 0, right? So similarly, what we will do, we will be doing the same thing here also, but before that, okay, that's one crucial step. Before that, we will be writing this particular vector as this, which means we will be writing the constants at one place and that s and t at one place, okay? And then you can decompose it further. How? Just like the way we did in the homogeneous. So let me just do it. So which means, maybe I can go to the next page. So here I can just tell you that what you can do, you can just write it like this, that can be decomposed into, see, this particular vector is as it is, so maybe I can just copy this as it is, right? This particular vector is as it is, so let me just copy this, and then you have plus one more vector by getting, like, or by putting s equal to 1 and t equal to 0, you will be getting one more vector, so that will be multiple of s. So s equal to 1 you put, this will be 1, minus 1, 1 and 0. And then similarly, by putting t equal to 1 and s equal to 0, you will be getting other vector, which is 1, minus 4, 0 and 1. So basically, if you notice that this story is same as the earlier, but only extra step is this. Okay, we are writing the constant separately and then s and t part separately. How we are doing so? We are putting all s and s0, t0 like this. Okay. See, one common mistake that you can do is this. Let me write the common mistake. So this is not the actual answer, but yeah, this is the common mistake that you can do, which is that you put all of them at 0 here, which means s equal to 0, t equal to 0, and then you get 2, minus 4, 0, 0. Yeah, that is fine. But you simultaneously you put in this only, okay, that will be a problem actually. You put s equal to 1 and t equal to 0. And then you say this is the factor of s. So if you put s equal to 1, then it will be 2 plus 1, right? 2 plus 1, it will be 3. And then if you put s equal to 1, it will be minus 5, then 1 and 0. So it will be 3 minus 5, 1, 0 plus t. And then similarly, you put t equal to 1 and s equal to 0. Then what you will be getting? You will be getting 1 plus 2 is 3. 1 plus 2 is 3. And then this is minus 4, and minus 4, this will be minus 8. This is 0, this is 1. So that's actually wrong. Why? Because you are adding this 2 minus 4, 0, 0, this vector multiple times. I mean, that's already there. You are adding it here also. I mean, see, earlier what you got is this. Earlier you got this one, right? Which means you got this 2 minus 4, 0, 0 separately, and then 1 minus 1, 1, 0. But instead of 1 minus 1, 1, 0, you are getting 3 minus 5, 1, 0. Reason being is that you are adding this into 1 minus 1, 1, 0. If you add 1 minus 1, then it will be 3, then minus 5. Basically, you are multiple times adding this 2 minus 4, 0, 0, because you are directly working with this, and that's where you got the problem. So first is that you write this constant separately and then apply the trick of s equal to 1, t equal to 0, t equal to 1, s equal to 0, like that. Okay. So you write this constant vector separately. So you need to write this constant vector separately and then you apply the trick. That's the only difference. See, if you compare the final answer, so this is the common mistake. Okay. So you should not do it. Now let's just go to the original answer. So if you compare this answer with the original or the earlier answer, which means this, then you will feel that both are almost similar. It was s plus t minus s minus 4t st, right? Here also you have the same thing, which means here also you have s plus t minus s minus 4t and st. But you got some extra vector. See, earlier we were solving for this equation, which was ax equal to 0. Earlier we were solving for ax equal to 0, right? And we got some answer. Now we are solving for ax equal to b, and now we also got some answer. And the difference in both the answer is that earlier we got only this one as answer, but now we are getting this one as answer. So basically, if you solve for ax equal to 0 and if you solve for ax equal to b, then both are almost same. It is just that one constant vector is difference. Okay, just one constant vector is different. That's the only thing. So I can say that ax equal to b or ax equal to 0 are actually sharing the same solution, but it's just that you are adding some constant to ax equal to 0 solution. Basically, it is geometrically, if you want, you can just try interpretation something like this. This is what all set of solutions of x which are satisfying ax equal to 0. So this is basically a hyperplane you can consider, which is basically ax equal to 0. And now there is a hyperplane that is actually ax equal to b. Now if you just can find out the perpendicular distance between these two hyperplanes, then it will be actually this. Why? Because you are just shifting your hyperplane to something, and then what x you are satisfying, what new x will be satisfying on this particular line, there will be this distance. So this distance can be calculated as 2 minus 4 0 0. See, you don't need to worry about this geometric interpretation, but still let me just tell you clearly what I want to say. Okay, before that, are you convinced that that this solution and earlier solution both are almost same? It is just that earlier we got this as answer. So let me write what we got earlier as answer. So earlier we got this as answer, right? Maybe I can write it there only. This is I can say answer for ax equal to 0. This is answer for ax equal to 0, right? And now let me write on the left hand, on the right hand side, let me write the answer for ax equal to b. And a is same, obviously a has to be same, otherwise like it will be completely different. So now this is the answer for ax equal to b, right? Okay, so this is the answer for ax equal to 0. This is the answer for ax equal to b. Now you just compare the difference that I am asking you to compare. This vector that we got earlier as answer, you don't worry about the decomposition, it is just another way of writing. Let's not worry about the decomposition because you can do that here also. But what I want to say ultimately is that this vector that you got there, right? Okay, and this vector you got here, like this vector you got here also, this vector you got there also. But the difference is that only this constant vector that you are getting here extra. So why we are getting this constant vector extra? That's what I wanted to convey. See, ax equal to 0 could be some hyperplane, something like this. This is ax equal to 0. And all the set of x which are satisfying here are can be represented, let's suppose, by something like this: s plus t minus s minus 4t, s and t, right? All the set of x which can satisfy this equation are represented something like this, right? Now you have another hyperplane which is actually ax equal to b. Now generally if you have seen in your 12th class, then y equal to mx plus c, this is one equation, or maybe y equal to mx plus 2 and y equal to mx plus 3. The only difference between these two equations of these intersect, right? So these two equations are parallel. So in higher dimension also, ax equal to 0 and ax equal to b are also parallel hyperplanes. Okay, you don't need to worry about what are the hyperplanes and all. I'm just telling you that there are two hyperplanes. One is ax equal to b, another one is ax equal to 0, and whatever x satisfying here will also satisfy there also. But you just need to take this gap also in the encounter. And what is this gap? This gap I'm talking about by this particular vector, which is 2 minus 4 0 0, right? So 2 minus 4 0 0. So the perpendicular distance or the vector here is this 2 minus 4 0 0. Okay, I hope you are a little bit convinced. Otherwise, this geometric interpretation is not required at all, right? So that's what I wanted to convey, that you can solve the non-homogeneous equation also. I mean, if it is having multiple free variables or the free variables, then you can solve it. The only way to rewrite it is that you have to just write it separately, and then you work with the homogeneous solution. So the homogeneous solution and non-homogeneous solution both looks like same. It is just that one vector it is different. Okay, one vector is different here. I hope you understood. Cool. So that's all I wanted to convey. And now let's just move to next set of questions using the rank. So we are moving to the next set of questions using the rank. Cool. Thank you.